All right, so now there are two different ways that we can calculate probability. What we're going to focus on right now is the classical or theoretical method for calculating probability. So classical probability is probability that is calculated through counting techniques. It's also thought of as a theoretical probability. Most of the time we will be using the theoretical probability of an event. So we aren't going to use the other method quite as much. Typically we'll be looking at, in theory, what is the probability of this event. So the probability of an event A is found by taking the number of ways that A could happen and dividing that by the total number of possible outcomes. So for example, you are flipping a fair coin. What is the probability that you flip the coin and it lands on heads? So I'm not actually going to flip a coin to figure this out. I'm going to use the theory behind flipping a coin to figure this out. So I want to find the probability that I land on heads. So the probability of a heads, let's put the rest of the letters in there, is found by taking the number of ways I could get heads, so there's one way to get a heads on a coin, over the total possible number of outcomes for flipping a coin. So there are only two possible outcomes when I flip a coin. So 1/2. We always want to report probabilities in their decimal form. We don't want to leave them as fractions, and we only want to take it as far as a percentage if we're explicitly told to do so. So in this case, it didn't ask us to turn this into a percentage, so I'm going to leave it. So the probability that I get heads when I flip a coin is equal to 0.5. So let's look at a little more complex of an example. So you and your friend are playing Monopoly. In this game, you have 2 fair die that you roll on your turn. You are currently in jail and need doubles to get out. Fill in the table to show the sample space for your next roll of the die. So remember, the sample space is a list of all possible outcomes. For this one, I went ahead and I put it in a table to help us organize it a little bit better. And actually, I don't want that pen color. I want blue. So the numbers in this first row represent the outcome on the first die. Then the column here shows what the number is on the second die. So for example, in this first empty box, this would tell me that I have a roll of 1, 1. Then I have a 2 and a 1, a 3 and a 1, a 4 and a 1, 5 and 1, 6 and 1. So in all of these possibilities, the second die was 1, and it was the first die that was changing. So these are 6 possible outcomes if I'm rolling 2 die, but it's not all of them. Now we have to consider all of the possibilities where the second die is a 2. So now we have a 1 on the first die and a 2 on the second die. Then we have a 2 and a 2, a 3 and a 2, 4 and a 2, 5, 2, 6, 2. So now I'm up to 12 possible outcomes, but I'm still not done. This row is going to be all of the possibilities where the second number is a 3. So keep listing these out. Oops, I messed those 2 up. This is 4, 3, 5, 3, 6, 3. I'm going to keep filling in this table, looking at what's the number on the first die, what's the number on the second die. And last column, and here we have the sample space for rolling 2 die. We have all of the possible outcomes if I roll 2 die. So now we want to find the probability that we roll doubles. So I want the probability of doubles. So doubles means that both of the die have the same number on them. So I need to find the number of ways I could get doubles. So that's 1 here, 2, 3, 4, 5, and 6. There are 6 ways to get doubles, divided by the total number of possible outcomes. So if I add up, or if I count all of the squares in my table that I filled in, these are all of the outcomes, I find that there are 36 outcomes. And we always want to report our probabilities as decimals. We also always want to report probabilities to a minimum of 4 decimal places. So when I plug 6 over 36 in my calculator, I get 0.166666 repeating forever. So I need to round that to the 4th decimal place. You always need to be giving 4 decimals with probability, unless it doesn't have 4 decimals, as in the first example. All right, so we did it. We got out of jail. Now we want to buy a property that is 8 spaces away. So we're going to find the probability that we land on a space 8 spaces away. So I want to know the probability that I roll an 8. Because in Monopoly, you get to move the number of spaces that show up on the die. So I want to look through all of my possible outcomes, and I want to find all of the ones that sum to 8. So right here, I'm starting here. I see 2 plus 6 would give me 8. 3 and 5 would give me 8. 4 and 4 gives me 8. 5 and 3. And 6 and 2. So there are 5 ways that I can get an 8 out of the 36 total possibilities. So 5 over 36 gives me 0.1389. So again, in these probabilities that I calculated, I did not actually touch a die in any way. All I have done is looked at what the possibilities are and counted those possibilities for the event that I was looking at. So this is the classical or theoretical method of calculating probability.